Hi class, in this lecture we will see what is recursion. So recursion is the art of programming where the concept lies that a function will call itself, right? Till now if you see the programs that we have seen is like we define the function in the main, print info, and then we call the function. When the function is done, you basically return from the function. But what happens in recursion is a function is calling itself. Let us see an example here. So I have a number 3 and I'm asking it to calculate the factorial. I hope everybody knows what the factorial is. So given any number, so you multiply from 1 to that particular number and the answer is factorial. So if I have a number 3, then 1 into 2 into 3, right? So when I'm asking it to calculate the factorial of this number, so there is a function called factorial. So the number is passed to that particular function. Okay, so what happens? The number is 3. So 3 gets copied into x, right? Now just see how what happens. If x is equal to 1, I am returning 1. Okay, so what does that mean is for any value which is 1, the factorial is 1, because we actually know that factorial of 1 is 1. In fact, we can make a slight change here, or x is equal to 0, right? Because factorial of 0 is also 1, factorial of 1 is also 1. Right? Else written x into factorial of this. See, now this definition, if you see this entire definition, when I expand, you will see that I am calling the factorial function from the factorial function. Of course, the first instance has to be from the main, because or else the function will never be invoked. The first instance goes from here. Then the factorial function is being called by the factorial itself. So now what happens? Our number was 3. 3 gets copied into x. X is equal to 1 or x equal to 0, false. So I will come in the else part. What happens in the else part? I'm just putting a hash here. X was 3. 3 into factorial of x minus 1, right? So what is factorial of x minus 1? Factorial of 3 minus 1, which is 2, right? So what happens when this function is called? So when this function is called, factorial with 2 is passed. Right? So what happens now? 2 is equal to 1 or 2 is equal to 0, false. So I come to the else part. So what does it return now? X into, what is x? X was 2. 2 into factorial of 2 minus 1. So let me put a double hash. Okay, let me add it like this. In the first attempt, this happened. Then we have 2 into factorial of 2 minus 1, which is nothing but factorial of 1. Now when factorial of 1 goes, x gets the value 1. If x is equal to 1, right? X or 0, so the condition is satisfied. X is 1 means I am returning 1. So what happens? Where does the return go? From the position it was called. It was called from this position. So factorial 1 will become 1, right? So what was factorial 2? Basically factorial 2 was this into this. Now factorial 1 is 1 because x equal to 1 return 1. So factorial 2 basically became 2 into 1, which is 2, and eventually this result came out 3 into 2 into 1, which is nothing but 6. Initially when you study recursion, it's a bit tricky to visualize it, and that's very normal. You have to make it a paper pen design and then you will understand. Sorry. Okay, so now what happens? So we have to just visualize recursion, and I am using this PowerPoint slide. Just check this. If x is 1 or x is 0, then we know that the number is 0 or 1. The recursion basically is 1, right? Even to avoid confusion, let me make this x as none. Somehow the refactoring is not working in my VS Code. Right, so number is 1 or number is 0, then I'm returning 1. Else what I'm returning? C, number into factorial of that n minus 1, right? Because factorial of 3 is 3 into factorial of 2, right? Or factorial of 10 is 10 into factorial of 9. Factorial of 9 is 9 into factorial of 8. Right? This is how it is going. Now just remember this particular line, okay? And we will see in PowerPoint how this takes place. See, I'm returning num into factorial of num minus 1, right? So I have factorial of 3. So this gave me num. 3 multiplied by factorial of n minus 1, which is 2, right? Now I am passing factorial of 2 will become 2 into 2 minus 1, right? So 2 into factorial of 1. And what is factorial of 1? Which is 1. So this one gets copied here. So this eventually becomes 1. So 2 into 1 becomes 2, which is nothing but factorial of 2. 3 into 2 basically becomes 6, which is nothing but the factorial of 3. So this is how recursion executes. It makes kind of a tree structure, like a binary tree structure. It goes and goes and goes in. With regards to the program that we have written, so you can see this. This is my loop, def factorial of n. N was 3. So when n is equal to 1, I am returning 1 because I know factorial of 1 is 1. Else, what I am doing, returning of n into factorial of n minus 1. So initially when n was 3, 3 into factorial of n minus 1 becomes 2. Now again I am passing this 2 to the factorial function. So what happens? N gets a value 2. This is falsified, else part 2 into n minus 1, which is 1. Again this function is called with the value 1. Now n equal to 1, so 1 is returned at this position from the point where the function was called. So now 2 into 1 is 1. This function was called by this function. So 2 into 1 goes here, which is 2, and 3 into 2 is returned. So 3 into 2, 6 is returned. Right? So that's it for this video. So thank you for watching. Recursion, usually at times it is recommended that you write your programs in recursion because it provides a very cleaner code. But in terms of memory requirement, it is heavy. Okay, so there are few programs which are well written, like Tower of Hanai or Quicksort and all. These are well defined using recursion only, easier to understand. But try to have a non-recursive approach most of the times. So thank you for watching. Have a good day.